All right, welcome to the lesson on like terms and the zero principle. Like terms are a very vital part of learning how to add and subtract monomials in algebra. Now, backing up a little bit, remember that a term consists of a coefficient part and a variable part. So as an example, negative 2a cubed is an example of a term because it contains a number part, again called the coefficient, and a variable part, which contains a base and an exponent. Now, when discussing what like terms are, we're talking about terms that have the exact same variable part. So the variable parts have to be identical. So thinking about negative 2a cubed, if I asked you, hey, think of a term that's a like term with negative 2a cubed. Well, there's a whole bunch of answers you could give me. In fact, you could give me any answer as long as the variable part was exactly the same. So, as an example, 3a cubed, hey, that's a like term because it has the exact same variable part. So is negative a cubed because, again, it contains the exact same variable part. But you know what's not a like term? Well, gosh, you could go with a lot of different things. Hey, here's an example of something that's not a like term. Let's go with 2b. That variable part is not the same as a cubed. Neither would be negative 5b cubed. That variable part is not exactly the same. It's important to know what like terms are, that they contain the exact same variable part. We need to know what like terms are when trying to apply the zero principle. So let's move on to talking about that now. The zero principle is used to cancel out or get rid of like terms. Now we're going to look at using algebra tiles to help us understand how like terms work and how we can use the zero principle. Here's an algebraic expression that we're going to work with. 3x plus 2x. No, pardon me. I'm going to change that. 3x minus 2x. There we go. 3x minus 2x. So to understand how this works, let's pull out the proper tiles. Well, here's 3x. And here's negative 2x. Now, when using the zero principle, it's just a matter of if you have two tiles that are the same, so like this guy and this guy, they're the same tile, but they're opposite, right? One of them's positive, one of them's negative. The idea with the zero principle is that they cancel each other out. In other words, they eliminate each other. So, eliminating them, I'm just going to pull them off to the side. So this one goes over here, as well as a positive tile that goes with it. And you can see, we can apply the zero principle one more time to get rid of these. And what we're left with right here is really the answer to this question that was asked, 3x minus 2x. Well, looking at what you got, the answer must be just x. In the next video, we're going to examine a little bit closer exactly how we do these adding and subtracting questions using pencil and paper. But basically, this is a subtraction question, a subtraction of two monomials. The two monomials being 3x, and the other monomial is negative 2x. And we basically made this a subtraction question, getting an answer of just x. Let's do one more example. 2x squared minus x squared plus 3x squared. Well, if you pulled out all those tiles, you would realize, hey, we've got like terms here. They all contain the exact same variable part. So we can use the zero principle to apply the zero principle to get our simplified answer. And if you look at it, it's just a matter of looking at your coefficients to help out here. So 2 minus 1 plus 3 is 4x squared.